Okay, ladies and gentlemen, thanks very much for joining us tonight, and this is of Pecha Kucha talks as part of Explorathon 2020. So, Explorathon, I should explain, is part of European Researchers' Night, which happens pretty much across all of Europe. It's European Commission funded, and it's the largest public engagement with research event in Europe, and it really seeks to bring research and researchers to the public in new and innovative ways. And we'd really love for you to tell us what you think of this event and the other events we've got happening as part of Explorathon. And you can do that by following us on Twitter or Facebook at ERN Scott, or by using the hashtag Explorathon 2020. There's also our website, which is www.explorathon.co.uk, and we've got lots of different events across Scotland, organised by different universities. So it'd be great for you to really get into it and see what else we've got going on. And tonight we're going to be joined by people from across Scotland, and I'll tell you a little bit about Pecha Kucha just in a minute, but before we do, just a note to say that we will be recording tonight's event. So Pecha Kucha is a very special talk format. It's short, it's snappy, it's visual, and it's fast paced. So the idea is 20 by 20. So that each speaker has 20 images and 20 seconds to speak about each image before the image moves on automatically. So they have got no more than 6 minutes and 40 seconds in total to talk to you. So it really encourages people to really condense down and be focused and think about what it is that they want to say to you. And we've got a great lineup of speakers for you tonight. And without further ado, let's start with Nathaniel Cole. So Nathaniel is a Marie Sklodowska-Curie Actions Fellow at the Rowett Institute in the University of Aberdeen. So Nathaniel's opening talk for us tonight is Go With Your Gut, How Our Gut Microbiota Protects Us from Infection. So Nathaniel, without further ado, over to you.
Hello everybody, my name's Nate from the Rowett Institute in the University of Aberdeen, and today I'm going to talk to you about our wonderful gut microbes and to introduce the exciting concepts that underpin my PhD project. You can see me here happily admiring my bacteria, trillions of which live on and in us and play a huge role in our health and also in preventing infections. Our bodies are colonized by numerous microorganisms, collectively known as the microbiota. The types of microbes vary between different sites in our body, but each site harbors millions of microbes. Today, my focus will be on our gut microbiota and how it specifically contributes to our health and to preventing infections. Now, with all of these microbial cells, you might ask, who are we? The statement that we're 10% human and the rest of us is comprised of microbial cells is a myth. There are approximately 38 trillion cells in the average human body and approximately the same amount of microbes. And I suppose you could say that makes us 50% human instead. Even with this 1-to-1 ratio, our bodies are getting pretty crowded. But who's in that crowd? It's mostly bacteria, and they make up 90% of the microorganisms that inhabit us, and mostly belong to the Firmicutes and Bacteroidetes phyla of bacteria, but there are also microscopic fungi and viruses too. I will mostly discuss our gut bacteria, and I will briefly mention our gut fungi, but you should check out Anne Kristen's talk for more about fungi instead. It's important to remember that not all bacteria are bad. Bacteria, as with other microbes, exist on a spectrum, with some causing infections. Others are extremely useful and essential for our health. Some are opportunists and may cause infections if certain factors are involved, for example, if they end up in the wrong body site or suddenly expand in number, and I will discuss why this might happen later. So how do we get our microbiota? In the uterus, we are sterile and begin to develop our microbiota as we are born. Babies of vaginal birth will have a microbiota that reflects their mother's vaginal and fecal microbiota, whereas C-section babies will be predominantly colonized by their mother's skin microbes. This microbiota is relatively stable in adulthood, but is still susceptible to change by a number of things. One of the largest influencers of microbial composition in the gut is the nutrients that we intake. The nutrients that escape digestion by our bodies and reach the gut are what our microbiota feeds on, and just like us, they have their preferences. For example, high-fiber diets will encourage the growth of Firmicutes, while high-fat diets will enhance the Bacteroides genus. And diet can be influenced by geography and lifestyle choices, which is why we also see geographical and lifestyle variance in the composition of the microbiota. For example, generally, in Western diets, they are higher in fat and lower in fiber, and so we see an increased abundance of Bacteroides and bile-tolerant species of bacteria. Another influencer is antibiotics, which are quite often broad spectrum, meaning that not only will they target the bacteria that is making you ill, but will also target your friendly gut bacteria. And it's the loss of these gut bacteria that means that we also lose all of the benefits benefits they have on us. What are these benefits? What makes the microbiota so important? Well, some of the foods we eat are undigestible to us. Often lumped into the term fiber, these complex carbohydrates are digested instead by our resident bacteria. Without the microbiota and its ability to digest our leftovers, we would be lacking some pretty important biomolecules that are essential for health, such as vitamin K, B group vitamins, but also neurotransmitters like dopamine and serotonin, which regulate our moods. And products of microbial fermentation, in fact, can also stimulate hormone production and play a role in the hormonal balance of our bodies. However, the most important and major byproduct of bacterial fermentation on our leftovers are short-chain fatty acids, or SCFAs, predominantly acetate, butyrate, and propanoid. 90% of these SCFAs are absorbed by the human body and have important physiological effects. Acetate is readily converted to more butyrate by the microbiota, and it's a good thing too, as butyrate is a major energy source of the cells that line our intestine. And SCFAs can also stimulate the immune system and prime it to be ready to act when needed. In fact, our microbiota and immune systems are intimately linked. During immune development as babies, our developing and fluctuating microbiota effectively trains the immune system to be able to appropriately respond to invaders. So you see, when our bacterial communities get disrupted, we lose so many of the benefits afforded to us by this symbiotic relationship with our microbiota. However, the most interesting benefit of the microbiota from my point of view and from the perspective of my PhD project is its ability to prevent infections. This ability to prevent infections is known as colonization resistance. The term was coined in 1971 when a series of observations showed that mice were more susceptible to infection by salmonella after antibiotic treatment, and this effect was linked to the depletion of their microbiota. There are several mechanisms in which the microbiota protects us, and I'm going to discuss that in the next few slides. First off, the sheer numbers of microbes present in our guts creates a physical boundary against potential pathogens. They block off any sites on the body surface that pathogens could latch onto and thus invade our tissue and cause infections. In addition, all of these microbes mean that there is some serious competition for nutrients. The importance of this nutrient competition is highlighted by studies that have shown that when disruptions cause reduction in the numbers of firmicutes and bacteroidetes, you see an increase in succinate, another SCFA, which is usually readily taken up by the microbiota. This increased succinate then acts as a nutrient source for opportunists like Clostridium difficile, which can overgrow and cause infection. So changes in the bacterial communities also results in a change in the landscape of secreted compounds, and that might include short-chain fatty acids, antimicrobial peptides, or immune regulators. And these can either directly inhibit the growth of pathogens or prepare the body's defenses against them. All of these mechanisms that we have discussed can also apply to fungal infections, but little is known about the relationship between host bacterial communities and the fungal component of the microbiota. And so this is the challenge of the Funhoma group, to try and decipher this relationship using the pathogenic yeast Candida albicans as a model organism for our studies. The gut is considered to be a significant reservoir for Candida albicans, which can live harmlessly in our guts, but is one of these opportunists that we discussed. In my project, I hope to be able to understand how specific species of bacteria contribute to colonization resistance against this yeast, and to pave the way for developing therapeutics to prevent and treat Candida albicans infections. And thank you for listening.
Okay, Nathaniel, fantastic. Thanks. Great opening talk there. Our second speaker tonight is from the University of St Andrews. She's a PhD candidate there. So this is Eleni Giamarello, and Eleni is going to be speaking to us tonight about how to become a goddess in 3 simple steps. So Eleni, take it away.
Hello everyone, my name is Eleni Giamarello, and today I will be talking to you about the thesis I developed during my MPhil. Our title is How to Become a Goddess in 3 Simple Steps. Caveat, please don't do anything that this character does. This character being witch extraordinaire and granddaughter of the sun, Medea. Medea is a prominent figure in Greco-Roman mythology, and the version we're going to be talking about today is written by Roman playwright and philosopher Seneca in the 1st century CE. In brief, her story before his play starts is this. Medea is a princess who betrays her family and kills her own brother in order to help Greek hero Jason secure a powerful artifact that was in her family's possession. Her and Jason escape together, get married, settle in, and they have kids. until Jason decides he wants to divorce Medea to marry the local princess of their new home city, because he is, academically speaking, arguably dim-witted. Returning to the subject in question, however, how does Medea become a goddess in this play? Well, she does so in the process of seeking revenge on her husband. The first step of that revenge process is utilizing her extraordinary magical talents. The play is specific enough in its description of her power to talk about her summoning storms, fire, and squeezing poison out of snake constellations. What would she want the poison for? Well, she wants to kill her rival. The princess Jason left her for has got to go. But Medea needs to take the poison and infuse it in some gifts. She can't exactly force the princess to drink it. However, there is a slight problem. Infusing the poison means making it imperceptible to the senses, so that the princess will be none the wiser. And that requires more power than Medea currently has. But there is a way to get it. So she performs a magic ritual. In this ritual, Medea not only changes the poison's nature, but her own by acquiring more power. How does that work? Well, according to the ritual theory of one Bruce Kapferer, when one begins a ritual, they create a space where the worries of daily life go away and they can focus on other things. Those worries for us, for example, would be political turmoil, financial difficulties, ecological disasters, stuff beyond our control. For Medea, those things are anything and everything related to Jason. So when one enters this space away from worry, they can focus on the component parts of their reality. Imagine a foggy mirror after a shower. The fog is the worry, and once you take that away, you get the clear representation of your identity, of who you are. And understanding that can help you change parts of who you are, emerge in a new reality. And that's what Medea does. She augments her already existing power. However, in order to make that power divine and cross the divine threshold, she needs help, which is why she turns to the goddess she worships, Hecate, the goddess of witchcraft. Imagine for a moment that you are Hecate. You are hanging about, listening to prayers and people asking for help with love potions, and you hear praise and tsunamis and fire being summoned in your name without you having to show up to help, because you have a very capable worshipper. When that worshipper really needed you there, you'd be there. That's the give and take there is in this ritual prayer. So Hecate shows up for Medea, and Hecate and Medea manage to make Medea divine together through a blood offering. Medea's blood, as I have mentioned already, is somewhat divine because she is the ground daughter of the sun. All she needs is a little bit of power boost. Her own powers, her goddess's powers, and boom. Captain Marvel with an infinity gauntlet. Now she can do whatever she wants. Much like that, she can make poison imperceptible and kill her rival and exact her revenge. But she is not done, because she is still hurt by Jason. His betrayal has destabilized her identity. Sure, she got divinely powerful, so that rectifies some of the stability she lost, but she's still connected to him, not as a wife, but as a mother. Her children are the manifestation of her and Jason's bond. She knows Jason loves them, and she wants to hurt him more than anything in the world, even more than her own hurt. After long moments of hesitation and physical nausea, she comes to a terrifying decision. Killing her children is the only way to go. Captain Marvel with the Infinity Gauntlet becomes Thanos. This decision is not easy on her, but it is made. And again, it is ritual that allow her to disentangle herself from Jason. Her first child she kills and sacrifices to the ghost of her brother, whom she had killed for Jason. The second child she kills in a sacrifice to her own pain. And for all that these murders are atrocious, she is not punished, because there is no rival to a goddess's power. She gets onto the flaming chariot of the sun and departs into the sky, which is Divinity Acquisition Step 3. The way we ascertain divinity in antiquity is difficult, but one thing we know is that gods exist in separate spaces than mortals. They can mingle with mortals, but they're usually in other locations most of the time. And so this is pretty much confirmation, and we know that Medea has changed her status from mortal to divine. So essentially our how-to is complete, but there's always more questions to ask. There's many more ascension narratives, though not as frequent, but they're all, most of them about men. So are there differences when the hero is male? Are they more sympathetic? How does the author describe that ascension process? Is it with a ritual? There's so many questions across time and space in Greco-Roman times, and so little time. Thank you everyone for listening to me.
Well, ladies and gentlemen, there we have it, how to become a goddess in 3 simple steps. So after that, we have Dr. Peter Hanlon, who works at the Institute of Health and Wellbeing at the University of Glasgow. So Peter tonight is going to talk to us about frailty in clinical trials. So Peter, it's over to you.
Hello, my name is Peter Hanlon. I am a GP and I'm a clinical research fellow at the University of Glasgow, and I'm interested in the concept of frailty, and particularly frailty in clinical trials, and how this can help us to make better decisions for how we treat patients within primary care. This is a photo of Doon Castle, which is in Doon where I work as a GP, and one of the best bits about being a GP is the wide spectrum of people that we get to look after. And I find this variety really great. One of the things that I'm particularly interested in is what happens when people perhaps get older and become frailer, and how we best look after them. So what do I mean by frailty? This is probably an unhelpful and quite stereotypical image of what maybe people think of when they hear the word frailty. And it doesn't really capture the great complexity that is people's lives, particularly as they get older. And really, it's difficult to boil people down to a single image like this. People often live complex, often very active lives with lots of interests and things they'd like to do. But frailty does occur, and what we mean by frailty is an increased vulnerability to decompensating or to losing function when someone's body system becomes under stress. I'll try and illustrate this using this block of tower of blocks that I made. So if you imagine our body systems like a finely balanced tower, each part of our body system plays a part in keeping that system stable. Over time, we may lose function or lose blocks. So that might be a long-term condition that we develop. It might be something else like loss of a partner or a carer. And that just makes our whole system a bit more vulnerable if it comes under stress. And by stress, it can mean anything which risks damaging that whole system. So here's one example of stress to this tower. This is my son who's about to knock it over. But in the context of frailty, stress may be something like an infection, or could be side effects from a medication, or could be something like a fall. And in someone who is more frail or living with frailty, and who has a number of these things which make the whole tower less stable, there's much more chance that they will suffer poor outcomes if their system comes under stress, and it can take longer for them to recover from what can be perhaps quite minor illnesses. Now, this is important in primary care and in managing patients because it affects the decisions that we make. It makes it very difficult sometimes to weigh up the risks and the benefits of some treatments that we might be recommending for managing somebody's long-term condition, for example. Often our patients end up on a large number of medications. And this can make it very difficult as well for us to balance what is right for an individual and what might actually benefit them while limiting the risk that we expose them to. And in people who are living with frailty, this balance becomes much more difficult to judge, and getting evidence to make good decisions is more difficult. We often rely on clinical trials. So these are the types of studies that test how well a drug or another intervention works. And we rely on them because they give good, unbiased estimates of whether a drug is effective for treating a condition or not. One of the difficulties, though, is that trials are often thought to exclude people with frailty. And this is because people with a number of long-term conditions may not be eligible for the trial. There may be other reasons why people living with frailty may find it more difficult to participate in a trial. But what this results in is an evidence base which is much more difficult to apply to people who are frail. So at the Institute of Health and Wellbeing where I work, we are interested on that bottom spectrum to try and inform the care and the management of people within a healthcare setting. And that's what we've tried to do, looking at this issue of frailty. Some of the work we've done has used what's called UK Biobanks. This is a big study of 500,000 people, and these are more middle-aged people, so people aged between maybe 40 and 70. And we found that actually a surprisingly large number of these people, even at this younger age, were living with frailty. And it's particularly common in people who had multiple long-term conditions. So frailty clearly doesn't just affect much older people. And also many older people won't be living with frailty. It's a much richer tapestry than that. And we can have degrees of frailty occurring at various stages in life, which have important implications for how we deliver healthcare and how we support patients to live well with their conditions. Turning back though to these trials and drugs and informing the treatments that we give to patients. The work we're currently working on is to see whether we can use data from existing trials to try and make better estimates of how to treat people who are living with frailty. And this is possible because some drug companies have begun to share some of their trial data, so make it available to other researchers to answer different questions to what the trial was maybe set out to answer. And we have found that we've been able to use existing trial data to go back and to measure frailty to see how common frailty is within trials. Our hope is that this will help to inform the balance of risks and benefits that we'll have to weigh up whenever individual treatment decisions are made with patients within a primary care setting and beyond that. And overall, our hope is that by better informing care, we can allow healthcare to be delivered in such a way that can support people to live happy, enjoyable and fulfilled lives, trying to avoid the sort of stressors that might make a frail person more likely to lose function or to decompensate, but really to promote health and well-being throughout the life course. Thank you for listening.
Okay, Peter, thanks very much. So our last speaker tonight is based at the University of Aberdeen, and this is Simon Jackson. So Simon Jackson is an early career researcher at the University of Aberdeen, where he works in the Institute of Medical Sciences. And tonight his topic are microbes. Are they really all that bad? So Simon, for our last Pecha Kucha event for this year, over to you.
Hi everyone, my name is Simon Jackson. I'm a PhD student at the University of Aberdeen, and in this presentation I will be talking to you about microbiology. In the world we live in today, we are often warned about the dangers of bacteria and various other microorganisms, which can't be truer than now with the current pandemic situation. However, are they really all so dangerous that we need to get rid of them at a moment's notice? Well, as can clearly be seen in recent history, there are a wide range of deadly diseases that are caused by a variety of dangerous microbes, with many having the appropriate treatments to treat or even cure, while others being incredibly deadly without any immediate and effective therapies available. Of course, some diseases that are caused by bacteria can easily be avoided simply by making sure that all food products are consumed within their expiration date and that they are prepared properly, thereby killing deadly bacteria that can cause debilitating food poisoning, such as the infamous Salmonella, which is commonly found in uncooked meats or eggs. With that being said, many microbe-related diseases can't be treated by simply maintaining good dietary practice, which is why there are such treatments available as antibiotics. The wide range of antibiotics that are available on the market means that almost any strain of bacteria can be dealt with. However, there are a few problems that are associated with these drugs. The first is that while antibiotics are effective in getting rid of most of the dangerous bacteria, they have the unfortunate side effect of removing the good bacteria that are found inside of our digestive system. And this can lead to an upset stomach if proper precautions are not taken, such as consuming probiotics in the forms of yogurts or other dairy products. Another problem with antibiotics is that they may not necessarily be completely effective in helping our bodies fight some bacteria. This is usually due to the overuse of antibiotics, leading to antibiotic-resistant bacteria, which is a major emerging medical problem in the world today. However, with all that said, we need to remember one thing. Bacteria are literally everywhere, and their numbers are so great that it is impossible to get rid of all of them, no matter how hard we were to try. Furthermore, it goes without saying that this is not a good thing to do, even if we could, especially when it comes to bacteria that live inside our very own bodies. Yes, you heard that right. We have bacteria inside each and every one of us. They reside mostly within our intestines, and they are incredibly important for our survival as they help us digest our food. As mentioned previously, they are more commonly referred to as probiotics. However, from time to time, bad bacteria may enter our bodies and cause diseases or discomfort, and these are the bacteria that should be removed with medication wherever possible. So, a lot has been said about the dangers of microbes, but what about the advantageous uses of them? Surely they can't all just be good for probiotics, right? Well, let's delve into some of the uses we have found and continue to find for microbes in a way that can benefit us as humans. To start with, microbes have been used or have been vitally important in our food and beverage industries for a long time now. One of their byproducts, carbon dioxide, is a key component for the fizz of soft or carbonated drinks, while the fermentation property of yeast has been used extensively in the production of bread, beers, and wine. And if you're a cheese or dairy lover, you should also appreciate microbes, as their fermentation properties are extended to the production of these products as well, with yogurts being of particular importance as a source of probiotics, as previously mentioned already. Another great use for bacteria. Have you ever driven past a farm and smelled the foul fertilizer smell? Well, as an alternative to the stinky fertilizer, bacteria fertilizers can be used instead, which will greatly help the growth of crops or grass due to returning valuable nutrients into the soil, while additionally not smelling quite as bad. On a related note, bacteria are also being used to replace chemical pesticides for a more natural means of preventing crop wastage that is not dangerous to the environment. I'm quite sure that this also brings peace of mind to shoppers, knowing that they may not be potentially ingesting dangerous chemicals if they don't wash their fruit properly. If you have ever needed to remove nail polish, you may be familiar with another product that is produced using bacteria, acetone. In fact, there are many different organic solvents that are produced using useful bacteria, including isopropanol, alcohol, and many others. Some other current applications of microbes that are advantageous to society include algae farms for the production of various products, from omega fatty acids to various biofuel chemicals, while some bacteria have actually been found to have the ability to break down crude oil, which would be a major help in cleaning up oil spills. In addition to this, it is also possible for some bacteria to actually produce electricity just from the air, provided, of course, that there is moisture in the air. And this is pretty cool if you were to ask me. This would obviously reduce the burden on using non-renewable sources of energy. But wait, there's more. Additionally, while it has been shown that medication does exist to get rid of bacteria, the bacteria themselves can actually be engineered to produce a wide range of medications to treat various ailments. One of the most famous examples of this is using bacteria to produce insulin, which can then be used by diabetics. Microbes are also being investigated, such as in my project, to be used to produce vital food additives, including vitamins, carotenoids, and exopolysaccharides, which can greatly benefit those that can't consume enough of these in their typical diet, such as vegetarians or vegans, or those with diseases that prevent their effective absorption, or alternatively for use in enhancing the flavor and texture of food products. But why would we want to do this if we already have methods that can actually produce these food additives? Well, the current methods are incredibly expensive. They also produce very small amounts of the food additives, and worst of all, they are environmentally unfriendly, requiring the use of very toxic components or producing them as byproducts themselves. So when it comes to bacteria, don't forget that while there are various different dangerous strains out there, there are plenty of beneficial ones that are used in medicine, food, industry, and also inside your very own bodies.
Okay, Simon, thanks very much for that, for a really strong closer for our last Pecha Kucha talk for tonight. So yeah, I really hope that you've enjoyed all of these talks. They were really interesting, and that's what's great about Pecha Kucha, you know, is it brings you so many different people doing so much exciting work in, you know, very different fields. And you know, it's also great that we're reflecting researchers across Scotland tonight. So I really hope that you've enjoyed these. I would like to thank all of our speakers for giving up their time to kindly share their research with us in such an entertaining way. I'd like to thank all ladies and gentlemen. Thank you very much for joining us tonight. But as I say, do follow us on Twitter, on Facebook at ERN Scot using the hashtag Explorathon 2020. I'd like to highlight the QR code that you see on your screen here. If you follow that, you will be taken to a feedback survey, and I'd really encourage you to do that if you have a moment, because it really helps us improve upon the programme moving forward. So hopefully you'll get a chance to do that. But in the meantime, thank you very much for joining us, and good night.